Process Compose runs several programs at once on one machine. Not containers, just processes. In this series, I'll cover what it does, how to configure it, and where it stops being the right tool. Here's the situation it's built for. You clone a repo, and the README tells you to start the database, wait for it, run the migrations, start the API, start a worker, and the frontend won't do anything useful until the API is up. So you open 5 terminal tabs. You start them in the right order from memory. 20 minutes later, one of them has died and you haven't noticed because its tab is behind 3 others. What you want is fairly modest. Start these programs. Start them in the right order. Wait until each one is actually ready, not just launched. Restart the ones that fall over. Put the output in one place, and when you're done, shut all of it down cleanly. The usual answer is Docker Compose, and if your stack is already containerized, use it. But containerizing a program purely to control its startup order is a lot of ceremony. You end up maintaining Docker files, volume mounts, and network definitions for code that runs fine as a local binary. The project's README puts it plainly. Process Compose is a single-go binary with no runtime dependencies. You describe your processes in a YAML file and run one command. This is a complete working config. 2 processes, and the second one waits for the first to finish before it starts. Run it, and you get a terminal interface. Every process with its state, how long it has been up, whether its health check passes, memory, CPU, restart count, and exit code. Logs for the selected row sit underneath. This is the demo project I'll use for the rest of the series. A small link shortener with a migration step, an API, 2 workers, a mail relay, and a static frontend. It is worth being clear about scope. This is a single machine orchestrator. It is aimed at local development, at running a stack in continuous integration, and at bundling a handful of services on one box. It does not schedule across hosts, and it is not trying to replace systemd for long-lived production services. If you need a cluster, this is not that. Over the next 9 videos, I'll go through installation and a first config, dependency conditions, health checks, restart and shutdown behavior, the terminal interface in detail, environment and templating, namespaces and replicas, the REST API, and using it in continuous integration. Next up, installing it and writing a config from scratch.